Okay, here we go. This is rational expressions, non-permissible values, and simplest form. And I'm going to get myself a pen. So, any rational expressions, any algebraic expression that can be expressed as the quotient of two polynomials is called a rational expression. In other words, they look just like fractions, except the numerator and denominator can be polynomials, as well as just numbers. Right? Here's some just numbers. And here's polynomials, 3x over x minus 2, x squared minus 4 over 3, and so on. And so if you'd like, you can pause, look these over, just take a look at the ones on your sheet. Non-permissible values. So a rational expression can be evaluated. All you have to do is give a value for the variable. So when x equals 4, this expression becomes 3 times 4 over 4 minus 2, which is 12 over 2, which is 6. What's the value of 3x over x minus 2 when x equals 2? Okay, so we get 3 times 2 over 2 minus 2 equals 6 over 0. Whoops, that's undefined. Okay, we cannot divide by 0. So some rational expressions are not defined at particular values, right? When x was 4, this is perfectly fine, but x equals 2, not so good. In particular, rational expressions are not defined at any value that makes the denominator equal to 0. Since substituting 2 into 3x over x minus 2 causes the denominator to be 0, we say that 3x over x minus 2 is not defined when x equals 2, and that 2 is a non-permissible. I really got to get some sound effects, I think. Non-permissible value. I'm going to have to work on that for some future shows. It's not really a show, is it? A non-permissible value of a rational expression is any value of the variable that makes the denominator equal to 0. I'm pretty sure there's nothing else there. To find the non-permissible values, determine all the values that make the denominator equal to 0. Period. The task, I think that's what it says, of finding non-permissible values can be asked in several ways. For what values of the variables each rational expression not defined or undefined? State the non-permissible values, state the restrictions on the variables. So you could be asked for non-permissible values, you could be asked for restrictions. For each rational expression, determine, and we actually are going to show some work here, and often we'll just be asked to state them. Determine the non-permissible values, that is, what value of x makes the denominator equal to 0. Where necessary, express all non-permissible values as improper fractions. Okay, so we know that 5x equals 0 will yield a non-permissible value, which means that x equals 0, and the non-permissible value is x equals 0. Here, if x plus 3 is 0, in other words, if x is negative 3, then we will have a non-permissible value. X is not allowed to be negative 3. It doesn't matter if the top is 0, right? The denominator doesn't matter if you put negative 2 in here. You'd simply end up with 0 divided by something, and 0 divided by something is simply 0. So here, it's x minus 1 equals 0, or x equals 1. 4x minus 3 has to be equal to 0. So 4x has to be equal to 3. And x is equal to 3/4. Now my fast way of doing that is take this with the opposite sign and put it over this. So this will be positive 3 over 4. And that's x equals 3/4. Here, 3x plus 2 equals 0. 3x is negative 2, x is negative 2/3. Rule still holds, right? Opposite sign of 2 is negative 2 over 3. X is equal to negative 2/3. We've got 2 here, right? If 6x minus 1 equals 0, meaning 6x equals 1, or x is 1/6, then we have a problem because this will be 0. And x plus 5 equals 0, meaning x is -5. So here we say 1/6 or -5. 2x. You're going to see this a lot, so watch out for this. When you see an expression, it means that 2x is equal to 0, so x equals 0, or 3x minus 7 equals 0. 3x is 7, and x is 7/3. So the non-permissible values are when x is 0 or 7/3, right? Expressed as an improper fraction. No, ever, 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 never a decimal, and don't do it as a mixed number. By inspection, x equals 0. It's going to cause problems here. X equals 0, y equals 0. If either of those are 0, this expression will be 0. M equals -4. A equals 5. Y is equal to -3/5 for the reason I went through before, right? This becomes -3/5. T is 2/3 or -1/5. Same reasoning. You can work these out if you want. I'm stopping doing that now. It's by inspection. But you would say 3t minus 2 equals 0, 3t equals 2, and t equals 2/3. Similar reasoning gets you this. And here, t, no t. X equals 0, or x is -7/6. Always an improper fraction, never a decimal. Moving on. Write an expression with the following restrictions on the variable. All right, what if I had like 2x squared over x, just as long as x can't be 0? Now, note one other thing here. We're saying restrictions. So a non-permissible value, we would say x is 0, t is 5. For restriction, we say x cannot be 0. So restrictions are simply the non-permissible values, but stated with a not equals instead of an equals. 3t squared minus 2t plus 7 over, this is really meaningless, it could just be 1, over t minus 5. -3/4. Okay, here's what I would do with this. Let's do this off to the side. Let's just say y equals 3/4, so 4y equals 3, so 4y minus 3 equals 0. So that means 4y minus 3 needs to be down here. And anything you want up here. -2. Okay, anything. Just as long as 4y, oh wait, that's plus 3. Yeah, sorry, that's -3/4. So 4y is -3, 4y plus 3. Okay, at least it changes with only adding a stroke of a pen. So 4y plus 3, right? And again, the rule holds, right? Make this negative, so -3 over this over 4. Two non-permissible values. You can't be 5, okay? So let's go x minus 5. And notice we use the variable t here, the variable y here. At least I'm just noticing this now. And x plus 2, and that's a factored form. Let's make this just 3x squared minus 7x, and we're done. 3 non-permissible values. So that means there are 3 variables or expressions in the denominator, one of which is 0. One of which will be x minus 4, right? Because if x were 4, this would be 0. And the other one is 3x plus 1, right? Change the sign, make that -1 over 3. There you go. There's your restriction. And let's just put that as 1 over, right? Or 11. Or 11x minus 17. Doesn't matter what's on top, right? It just matters what's on the bottom. There are 3 non-permissible values. There will be 3 expressions corresponding, each one corresponding to a non-permissible value, or as we've now started stating them as restrictions, and the difference is non-permissible values say what x is. If x is 0, we got problems. And restriction, you say that x is not allowed to be 0, or x cannot equal 0. Okay, first, let's fix this. This should be a 4. I don't know what it is on your worksheets, but it's a 4 here. Fractions are many equivalent forms. So 10 over 20 is 4 over 8, is 2 over 4, and ultimately it's 1 over 2. These are all equivalent to 1/2. We say that 1/2 is the fraction in simplest form. I would say they're mutually prime, which means that there's no number that divides into both. See, here both are divisible by 2. Right? That can't be a 6. Oh no, you know what? It could be a 6. Never mind, let me get out the eraser. I was thinking it couldn't be, but of course it could. This would be 3 over 6, which is also equivalent to 1/2. Never mind. Likewise, rational expressions that appear to be different may in fact be equivalent. So if we can get every rational expression in its simplest form, then we can decide on equality. To simplify a fraction, we divide numerator and denominator by their greatest common factor. For example, 10 is equal to 10 times 1, and 20 is 10 times 2. And the 10s cancel out, leaving you with 1. 1 times 1 over 1 times 2, or a half. Another example, well, the biggest number that goes into 24 and 18 is 6. The x squared, so in this case we look and we say x is common to both, and x squared is the smallest value that goes into both. So I'm going to put an x squared there. And this is y cubed, this has a y, so we go with the smallest power. So what we're really looking for is the greatest common factor, right? So the numbers, it's 6. Of the variables, it'll be the smaller of the two, right? They need to be both. It needs to be common, and it needs to be the smaller, so x squared, and the smaller of these two, which is y. Okay, 6 times 4 gives me 24, right? Because you'll have to fill this in. I need an x squared. I've got it. I need y cubed. This will give me y cubed. This 6 times 3 gives me 18. X squared times x cubed is x to the 5th. Multiply powers with the same base, you add the exponents, and we've got the y. These guys cross off. And in simplest form, we have 4y squared over 3. So, simplest form, you cannot have an x on the top and an x on the bottom. You cannot have two even numbers, right? You can't have a 9 and a 3. You would need to reduce that. If there are any common factors left, then you didn't find the greatest common factor, and you need to keep simplifying until you cannot simplify anymore. Okay, in the table below, each row contains a rational expression that is not in simplified form. Okay, here it is, just some basic rational expression. Express each rational expression in its factored form. So that's our first step. Factor everything. Numerator and denominator. Then state your restrictions, and restrictions are always from the denominator. And remember, restrictions are of the form x is not equal to, this will be 3 over 2, 3 halves, and this is that x cannot equal 2. Once we've done that, we can then say, hey look, I've got this crosses off. When we cross it off, we put ones there. Don't just, cross it off and throw it away. There's a 1, and we're left with 5 over 2x minus 3. This is the simplified form. Nothing goes into 5, 2, and 3, right? They're mutually prime. And the thing is, what that says is that this expression, and this expression will evaluate to the exact same thing every single time, as long as x is not 3 halves or 2. Because if x is 3 halves, well, this one has problems. It'll be undefined, and so will this. But if x is 2, this is defined, right? Put a 2 in there. You get 4 minus 3 is 1. This will be 5. This will be undefined if x is 2. So we have to state our restrictions off the factored form before we do any canceling, and then we can reduce. So these two expressions are the same as long as you're not using those values of the variables. Any other value, they will be. You can try it yourself. Okay, step 1. Factor. Now here's the thing. When we ask you to do this, most of the time there's going to be some common factors. There'll be some canceling, right? So pick the easiest one. I don't know, how about this? It's x minus 3, and you use whatever factoring method you like. Right, after grade 10, we stopped caring. You know what? If there's going to be a common factor, it's going to be x minus 3. And then this will have to be x minus 1. Let's check these out. X squared plus 2 minus 3 is minus 1 minus 6. X squared minus 1 minus 3 is minus 4 plus 3. Good. So always check your factored form before you go on. If this is wrong, everything else is bad. Okay? Restrictions. Restrictions always from the factored form. X cannot be 3 or 1. Let's list those in order. 1 or 3. You can cancel the x minus 3's. It's often, almost 99% of the time, it's going to be when you do the factoring that you'll be able to cancel something. And we are left with the simplified expression, which is x plus 2 over x minus 1. We are not solving here because we cannot solve. All we can do is simplify. And so your expression or your instructions will be simplify. Okay, factor the top. Trick it is. Factor the bottom. Two terms with a plus. The only thing you can do is a common factor. This will be x times x plus 3. State the restrictions. Remember, not equals to restrictions. 0, negative 3. Right? Can't be 0, can't be negative 3. The x takes out the x squared, leaving an x. So there is an x to the 1 here. This top numerator is 5x. Denominator x plus 3, and if you ever cross these off, I will cross the whole thing off and give you 0 marks. These do not cancel. This is 5 times x, this is x plus 3. Anytime you're thinking about doing cancellation like that, just throw a value of a variable, and if you cancel these, you'd be left with 5/3, but if you put a 1 in here, you get 5 over 4. If you put a 2, you get 10 over 5, which is 2. So, you know, anytime you're thinking you can go simpler, just try and verify that with a value. Okay, GCF is 3, so it's 3 bracket 2x minus 1. Means I bet you one of these factors will be 2x minus 1, because it certainly can't be a 3. This is a difference of squares, and we factor 2x plus 1, 2x minus 1. Now we state restrictions, okay? Don't do it here after you've canceled. You must do it before you cancel. X cannot be plus or minus 1/2, right? That's negative 1 over 2. That's positive 1 over 2. Now we can cross off. Putting 1s, 3 times 1 is 3. And on the bottom, or if you want to be technical about it, the denominator, 2x plus 1. Step 1, factor. Okay, I see 2x. Matter of fact, I'm going to go with negative 2x, giving me 3x, right? That gives me negative 6x squared, plus 2. That gives me minus 4x. Check, 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 check. Always check factoring. Okay, here, I'm going to bet you money that one of the factors is 3x plus 2. So to get a negative 6, I'm going to need an x minus 3. Now, I didn't really factor that, right? I sort of simply said, hey, if we're going to end up with 3x squared, this will be an x. And if we're going to get a negative 6, because the last term only comes, then that has to be negative 3. That was sort of a guess. Now I'm going to verify. 3x squared minus 9 plus 2 is minus 7 minus 6. Ha, it was right. Now, restrictions, right? We do not cancel anything. Negative 2/3, positive 3. Negative 2/3, positive 3. Now, we cancel. Oops, I canceled right off the tablet. And we are left with negative 2x over x minus 3. Simplified form. Ooh, what's easiest? Well, we got an x squared that's coming out and a 4. So let's do the bottom. Let's get a 4x squared. And this will be 2x minus 5. What does that mean? It means, dollars to donuts, one of these factors is 2x minus 5. Let's just write it above so that we'll cancel them. To get a 2x squared from the first term, I'm going to put an x in the front. And to get minus 15, when I've got minus 5, let's go plus 3. I haven't factored this, right? I didn't factor. I'm simply saying, hey, I bet you one of these is this. Okay, let's check it out. 2x squared minus 5x plus 6. Minus 5 plus 6 is plus 1. minus 15. Hey, it works. X cannot be 0 or positive 5 over 2. 0. 5 halves. Cancel. And state your simplified form. X plus 3 over 4x squared. And that's all he wrote. Except it's not, because we still go on, right? But I'm just going to talk fast and try and get through this, because this is a fairly long worksheet. So write the 3 steps on how to convert. So factor. And when I say factor, it means fully factor. Factor numerator and denominator. Step 2, state the restrictions. Okay, restrictions are only on the denominator, only for the denominator. And they are the values of the variable that will make the denominator 0, which will cause us to divide by 0, which will cause us pain. So we're not going to do that. And then we cancel common factors. In numerator and denominator, and we write the simplified form. Okay, write simplified. I'm drifting down my tablet here. Form. But hey, there's nothing else on this page. And we're on page 27 of 86 pages, I think. And oh my god, there's like 400 of these, so I'm just going to buzz through them quickly. So simplify each of the following rational expressions and state the values for which it is not defined, that is, state the restrictions. There is, okay, just m and n, so let's start off with restrictions. M cannot equal 0, n cannot equal 0, okay. This will be -1. This will be 8. 6 goes into 8. The m, this will be m squared. That takes care of the m. The n squared makes this an n cubed. So it's -m squared over 8n cubed. If you notice any mistakes, let me know so I can come in and fix them. First step, factor 6 bracket x minus 2. 5 bracket x minus 2, restriction, x cannot be 2, simplification, this is equal to 6/5. Always, right? They're identical. It doesn't matter what it is, it's going to be 6 over 5. Okay, so I put a 0 in there, I get -12 over -10, which is 6 over 5. I put a 1 in there, I get, let's put a 2. I put a 2 in there, I get 0 over 0. Okay, can't do 2, right? It says right there you can't do 2. How about 3? We get 18 minus 12, which is 6, over 15 minus 10, which is 5, 6 over 5. Always 6 over 5, as long as x is not equal to 2, because that's the restriction. It would make this 0, and that's definitely not that. Okay, factor 3, x plus 5. 2 terms with a plus sign, only factors with a common factor. 6x, x plus 2. Oh, I'm kind of depressed here. So x cannot be 0 or -2, right? That comes from here. There is a little bit of canceling going on. And we end up with x plus 5 over 2x bracket x plus 2. No other canceling to be had in this. You know, we didn't get the usual thing with Calgary-Dallas game has started. We didn't get the usual thing with you know, something canceling here. So this, but this is simple as it goes, right? There's nothing further that can be done to cancel. Okay, there's like 17 more, I think. So let's get through them. Okay, factor 2 bracket x minus 4. 2 terms, common factor, or it's a difference of squares. You know what? One of them is x minus 4. The other one has to be x plus 2. Check it. X squared plus 2 minus 4 is -2 minus 8. Yes, huzzah. Here, let's split this off here. Let's write in our restrictions. X cannot equal 4 or -2. So let's go -2 and 4. It's got nothing to do with this. It's all down here. These cross off, and we get 2 over x plus 2. Moving on. Easiest thing to factor is the denominator. That's a difference of squares. So it'll be 2x plus 5y and 2x minus 5y. Okay, it means one of these guys is 2x plus or 2x minus. That's a plus, which means both signs are the same. That's a plus, so they're both positive. Therefore, it is 2x plus 5y. Now, this is a bet. This is not a guarantee. So to get 2x squared, I'm going to put an x in there. And to get 5y squared, I'm going to go plus y. And now I'm going to check this. 2x squared plus 2xy plus 5xy, which is plus 7xy plus 5y squared. Yay. This says that 2x plus 5y can't be 0. I'm actually going to write 2x plus 5y. As a restriction, we say not equal to, right? And, you know, we get this kind of, you know, like 2x cannot be -5y, and x cannot be -5y over 2, and because that's the same deal but with the plus, then x cannot be plus or minus 5y over 2, and similarly you could have solved it and said that y can't be whatever y can't be. We're a little less concerned about, at least I am a little less concerned about restrictions. This restriction is actually a little line, right? If you do it in terms of y, so let's do this one. 2x minus 5y cannot be 0. -5y cannot be -2x. So y cannot be positive 2/5 x. Now really it's plus or minus, because if we do this one, we'll get a minus in there. That's another way. That's a line, right? Y equals 2/5 x. It's, you know, a line with a slope of 2/5, and this is the other line with the slope of -2/5, and they kind of cross. And you cannot be anywhere on that line, or this expression will be undefined. Okay, now we cancel, and the simplified form is x plus y over 2x minus 5y. Moving on. Last one. Ooh. I think something happened in the football game that I have in the background because I can't do football. And x plus 2. Okay, you know what? You're going to get an x plus 2. So let's write it out. Let's do it over here, x plus 2. How will I get 3x squared? You put a 3x in there. How do I get a minus 2? You put a minus 1 in here. Check it. 3x squared. Plus 6 minus 1 is plus 5. Minus 2, huzzah, it works, right? Not always. They don't always cancel, but you know, in this case it does. Don't forget the equal sign in front, because this is equal to that. State your restrictions. X cannot be positive 1/3 or -2. That comes out of here. Cross, cross, 1, 1. 5x over 3x minus 1 with yawn restrictions, right? Did I state? Yes, we did restrictions here. They're just kind of really ugly restrictions there. Okay, I think there's only 7 more. No, I lied. There's like 3. Difference of squares. 2 terms. Factoring. You always look for common factors, not there. There's a minus sign, then you think, hey, this could be a difference of squares. 3 plus x, 3 minus x. Over. Now, you know what? Let's go x plus 3. Wait. Let's go back to what we had originally. I would pause and rewind, but I'm talking fast enough that it shouldn't matter. 3 minus x, 3 plus x. Okay, so we got to have a 2x, right? That's the only way. If we're going to have, let's say this was x plus 3, then could we put like an x plus 3 here and a 7 here? And what would that do? I think that would do it, actually. So let's go with a 7 here. Let's go with x plus 3 here. Then we need a minus here. Let me try this. 2x squared. Plus 6 minus 7 is opposite signs. Your signs are wrong. Okay, so hey, here's guess and check, right? And this was a good one to happen. 2x squared. Plus 6x minus 7x is minus 1x. Oops, wrong. That needs to be a plus, and that needs to be erased, and that needs to be a minus. Okay, now let's check it. 2x squared. Minus 6x plus 7x is plus 1x minus 21. Okay, it's really sort of this, but with a negative thrown in for good measure. But first, we state non-permissible values. So it can't be 3, and it can't be -7/2. -7/2 cannot be 3. Okay, these two guys. They're the same, only they're not, right? Because the signs are opposite. This is a positive 3, negative x. This is a positive x, negative 3. Cross this off, write a negative 1 in to handle the fact that really we're going to flip the signs on this. That's what the negative will do. Then we can cancel these. So up here we get negative x minus 3 over 2x plus 7 with these restrictions. And life is good, and I think, honestly think there's only 2 more left to go. Difference of squares, which is then going to be another difference of squares, because this is a perfect fourth, and this is a fourth, and, you know, if you've been around these long enough, you'll see stuff, and then, oh my, this is like one of those, and okay, let's do it. Okay, so this is 4 minus x, no, let's go 4 plus x squared, 4 minus x squared. Let a equal x minus 3. This is a squared plus 7a plus 6. Keep going. We're not stating restrictions yet because this is not yet factored. This is 4 plus x squared. This is another difference of squares, 2 plus x, 2 minus x. I'm willing to bet one of these guys is going to come out once we x that. So here, let's do this. This is a plus 1, a plus 6. But a is not a, right? So it's x minus 3 plus 1, and x minus 3 plus 6. Okay, keep going. 4 plus x squared, 2 plus x, 2 minus x. We don't have the denominator factored. That's why we are not yet stating the non-permissible values. This is x minus 3 plus 1, or x minus 2. Hey, that's only backwards. Okay, so and this is x minus 3 plus 6, which is x plus 3. Now, restrictions, because now we have the values, right? So x cannot equal 2 or negative 3, right? Go ahead, try it. Stick a 2 in there. 2 minus 3 is negative 1. Squared is 1. Put a 2 in here. 2 minus 3 is negative 1. That's 1 minus 7 plus 6, which is 0, right? Ooh, bad. Can't do that, right? And same thing, if you put a negative 3 in there, you'll also get 0. Okay, this takes out this, but this becomes a negative 1, right? Because the signs are opposite. Just do it. I'm not going into huge and gory detail. So negative 1, x plus 2, just rewriting that. X squared plus 4, just rewriting that. Over, nice dip. X plus 3. Done, right? Here's your restrictions. This is your simplified form. There's nothing else to do. This doesn't factor. That doesn't. Nobody factors. Everything's done. Next. I think that's the last one. It is. Yay. Okay. Well, what do we have in store here? The top factors nicely. Here, let's just go down here. Let a equal x minus 1, 2a squared plus 5a minus 6, 2a, and 3. Let's go minus 3, no, plus 3, minus 1, 2a squared plus 6a minus 1a is plus 5a, 3. Wow, okay, wait. Hey, somebody scored. Hang on, I'm going to check that while I figure out how to factor this. Dallas scored, 404 in the first. Yeah, go Flames. Alright, it's a 2a and an a, but it's not a 3 there and a 1 there, because that's 2a squared plus 6a minus, I got the plus 5a, but I've got minus 3. So, can I put a 6 here and a 1 here? Would that work? That'll give me the 6 and 1. Nope. Go back up here, take a quick look. Yeah, okay, yeah, that's what that is. Okay, scratch. 2a, a. Okay, how about 2 and 3 to give me a 6? So if I put a 3 there, that'll give me a 6, and a 2 there will give me a 2. If I put a 2 there, now, let's see. That's a plus, that's a minus. Going back here again, 2a squared plus 5a minus 6. You just get to sit here and suffer with me, because you've probably already seen what it is, and I haven't. If I put a 6 there, I'll get a 12, so that won't do it. So I don't see a 6 and a 1. 2a squared plus... Yeah, I'm going to get to the point where I just expand this out, but I'm not there yet. But maybe I should get there. If I put a 2 there, I'll get a 4 and a 3. I can't get a 5 out of a 4 and a 3. Don't forget a squared is 2a. Okay, I'm stumped. Do 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 do. So I'm just gonna do 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 what you do 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 do. Sometimes. Okay, it's 2 bracket x squared minus 2x plus 1 plus 5x minus 5 minus 6 is 2x squared minus 4x plus 2 plus 5x. Let's go minus 11 here. Let's just sort of do this. Okay, 2x squared plus x minus 9. Okay, 2x squared minus x minus 3 over 2x squared plus x minus 9. Okay, let's factor 2x and x. If I put a 3 there and a 1 there, and I need a minus, let's go with the plus. So we get 2x squared plus 2x minus 3x will be minus 1x minus 3. Okay, and let's try a 2x minus 3 here, and then an x plus 3 here. So what do we get? 2x squared plus 6x, no. This is just like really depressing now. I'm at the point where I'm, you know, I don't think this factors. Okay, so either there's a problem in this or whatever. Talk to me in class. This is not happening. This is not, what's the only other possibility? 2x. What if I had an x plus 1? Because I'm just looking to say, will this cancel? What if I do? Then that'll be x minus 9. That's 2x squared plus 2, 9. No. This is depressing. 2 squared plus 5a minus 6. You know, without the 2 in front, I think. Anyways, that's it. I'm done. Done. Figure this out. If there's anything wrong with it, I'll fix it and throw in like a huge text box here and fix it up. But for now, done. See you in class. Talk to you later.